Hello everybody. Today we're going to be going over rubber ducky debugging. Now, this style of debugging doesn't depend on any software or any tools or anything like that, like a lot of our other debugging videos are going to be about. This one is more of a mindset or something to keep in mind while you're programming, and also a way to run through your program to better help you understand the program. The origin of this debugging style was there was a computer programmer who would carry around a little rubber ducky with him. And whenever he'd have a problem with his program, he would sit there and he would explain his program to the rubber ducky. And by doing so, he'd be able to better understand how his program worked, what he was going for, and where the problem in his program probably was. Because if you're able to dumb down your program to a point where a little rubber ducky could understand it, then you're probably doing a pretty good job and you probably don't have that many errors in the program if you're able to dumb it down to a way that makes sense to a rubber ducky. So to demonstrate this style of debugging, I've prepared a CPP file for it. If you're using the GitHub, it's the rubber main on line 8 of the main. We'll just uncomment that one. If you're not on the GitHub, then you can just go to the description of the video. The program's just going to be there, errors included, so you can follow along. And then what we're going to want to do is we're going to want to go to our rubber main.cpp. So here we have our program. And what this program's purpose is supposed to be, or what it's supposed to be, is that you input 3 values and then it calculates an answer from those 3 values. The equation specifically is x plus y times z, and it just calculates the results of that and then displays the results in comparison to 50. So it says if it's higher than 50, lower than 50, or equals 50. So if we run this program, it'll prompt us for x. Let's say x is 3. Prompt us for y. Let's say y is 10 and z is 5. All right. So what this equation is it's supposed to be x plus y times z. So we'll start by multiplying our y by our z. 10 times 5 is 50, plus x, which is 3, should be 53. Now, the number that's returned is 71, which is not what we're wanting. I mean, the is greater than 50 part is correct, because 53 is greater than 50, but the number that we're getting back is wrong. So, in order to fix this, let's do some rubber ducky debugging. And I've already prepared a little rubber ducky here for me to explain the program to. You see, he's cool. He has these cool little sunglasses too and everything. He's awesome. All right. So to start off with rubber ducky debugging, you'll want to define what your program's purpose is and tell it in such a way that a rubber ducky could understand. So what this program is supposed to do is you're supposed to prompt the user or ask the user for 3 numbers. And then you'll take those 3 numbers and you'll plug them into an equation. So we're going to take one number, add it to a number, multiply that by another number. And then we display the results and we compare them to 50. So we're going to say, do these 3 numbers, the answer of these 3 numbers in this equation, is that greater than 50, less than 50, or equal to 50? And that's the whole point of our program. So anything else that's outside of that doesn't belong in this program. It's unnecessary. So to start off, we'll just start at the very top of the program. We'll explain it to the rubber ducky here, and then we just step through the program one line at a time, explaining it to the rubber ducky in a way that it could understand. And by doing that, we'll help ourselves also understand the program. All right, so to start off, we are declaring our libraries. And what this basically does is that when we declare a library, we're basically saying anything in this library that we're going to use can now be used later. So we don't have to write out in C++ how to print things or how to get information because we have this library. This library is a bunch of functions that already exist, and we can just pull from those libraries. And that's what all these things, all of our programs are going to start with, the include IOStream using namespace std, because these are just really good libraries that we use. Otherwise, your cout and cins wouldn't work. So without this, we wouldn't be able to prompt the user for anything. All right, and then our program starts. So what we're doing here is we're basically saying these are the variables we're going to use. These are the things that we're going to put data into, that we're going to then store data in, and then we're going to get data out of later. This basically helps us store information to put into an equation later. That's the whole point of this, is that we're going to put info in here, and then we're going to store it for the equation, and then we're going to print the equation. And that's what the whole point of this is, and that's all these variables are going to be used for. And now here is where we're gathering the input or gathering the information. We're basically asking the user, put in the input for X, put in the input for Y, put in the input for Z. And then it's going to return those values and store those into the variables that I talked about earlier. And here's where we're going to do our expression. We're going to take X, add it to Y, and multiply by Z. So what's going to happen first is Y is going to times by Z, and then we're going to add X to it. And so the numbers that the user inputted first, that's what's going to happen to them. Whatever they inputted for Y is going to get multiplied by Z, and then added by X, and then that's going to get stored off into overall int that we're then going to use later to input a result. Now, there seems to be an X times equals 7 here. I don't really know why that's there, because I don't think that has anything to do with our expression or our point of our equation here. So that's probably unnecessary, but we'll just continue going on through the program. So here we are checking to see if our result is greater than 50. If it is, then we print that our number is greater than 50. If it's less than, we print our number is less than 50, and else our number equals 50. All right, so from what it looks like here, from me explaining this program to this little rubber ducky, the only line of code here that doesn't make sense or doesn't help with our purpose of our program seems to be this line 26 here. So thanks to our cool little rubber ducky here, we can now see that this line 26 here probably isn't that important. So if we just get rid of that, save the program, and run the program, and I input those three numbers, 3, 10, 5, then we see that our number is now 53, and that is greater than 50. So now our program is working correctly, all thanks to our cool little rubber ducky that we were explaining it to. So the main takeaway of this debugging style is that you don't actually need a rubber ducky. You just need to step through your program part by part and explain why that part is necessary for your program. And by doing so, that will help you better understand your program and see parts that don't make sense. Like that line 26, multiplying X by 7, maybe that was an idea in the past of something to do with this program. I don't really know what that would have done or how that would have helped anything. But perhaps that was some idea in the past that you just forgot about, and then now it's just causing problems for your program. So then you come back to it and you see it there and you're like, well, that doesn't actually help with this program. That's actually just hindering it. So then you can change it. And that's what the rubber ducky style of programming is really good for, is just explaining this program in such a way that a rubber ducky who knows nothing about programming could understand. So I hope this video was a help to you, and I hope you have a great day. Goodbye.